Good morning, Rohan. How are you doing?
I'm doing good, sir. How are you doing?
Very good, very good. So, in the last class, we touched upon the trigonometric ratios. Did you understand the primary trigonometric ratios?
Yes, sir. I was able to have a grasp of the primary trigonometric ratios and starting to learn about the secondary
Yes,
trigonometric ratios and their cofunctions.
and the coefficients. Also, we will today look into the inverse of these trigonometric ratios. Inverse helps us to find the angle. Uh, in yesterday's or last time class, we discussed how do we calculate the trigonometric ratio itself when the sides of the triangle are given to us. Now, we will see if the sides are given to us, how do we find the angle also, and then calculate the trigonometric ratios. Is that okay? So, let me share with you the chapter which I prepared for you. We'll begin from there. So, the very first screen, I think, is familiar to you. So, we have a table here, and on this table, as you can see, we have the name of the ratios. You have to get familiar with these names. It takes some time to begin with, but then soon it becomes like a common language for you, right? So the first row itself gives you what is sine. So as you will notice, all the names start with lowercase. This is very important because I have seen many students writing with capital letters, which is not correct. You have to write all the names with lowercase. So in the first column, I've given you the full form: sine A, cosine A, tangent A, cosecant A, secant A, and cotangent A, correct? So you may not take the notes for this now because I'll share the video with you so you'll get more time to write it down, okay? Now in the second column, I'm writing the abbreviations. Most of the time, in every book and everywhere, we refer to these ratios with their abbreviation. SINA, sine A, you have to say, right? It is not sin, it is sine A and cos A, tan A, cosecant A, secant A, and cotangent A. So the names remain same when we call or read these functions or the ratios, but we can write them in short, as you can see in the second column. Is that clear to you, right? But you'll always call them by their full name. You get the idea,
Yes,
okay?
sir.
Now, definition, to remember the definition, the acronym which normally used in North America is SOHCAHTOA, where sine is the ratio of opposite over hypotenuse, cosine is the ratio of adjacent over hypotenuse, and tan is the ratio of opposite to adjacent side. I sometimes prefer to write this as shown here, sine as SOH, right? Sine is opposite, so kind of a ratio as shown here, right? So which we may sometimes, in short form, while taking the class, I may write sine A as O over H, saying opposite over hypotenuse, cos A as A over H, saying adjacent over hypotenuse. What am I trying to say here is that if I have a triangle, which is a right triangle, okay, assume this is a right triangle. In that case, we'll refer to this angle as A, for example, and this side is opposite to A, that is adjacent to A, and that is the hypotenuse. Is that clear to you? Most of the time, we'll refer to the angle as theta. Now, theta, as you know, is a Greek symbol, right? So these three are the primary trigonometric ratios, and the other three are secondary trigonometric ratios, correct? Which we touched upon last time. Now, secondary trigonometric ratio, cosecant, is reciprocal of sine, and therefore you can see here we have written this as what? We have written this as 1 over sine A, basically. Secant is a reciprocal of cosine, and cotangent is a reciprocal of tangent. Is that clear to you? So these are reciprocal ratios in a particular triangle. If you find one, the other one is a reciprocal number. Now, things to remember is sine A, cos A, tan A are called the primary trigonometric ratios. Cosecant A, secant A, cotangent A are called secondary trigonometric ratio. Secondary trigonometric ratios are reciprocal of primary trigonometric ratios. Trigonometric ratios have no units since they are ratio of the size. The units cancel if they are ratios, correct? All trigonometric ratios are written in lower case. Most of the time, we work with primary trigonometric ratios, sine, cosine, and tangent. Greek symbols, alpha, beta. Let me write down clear. Alpha, A-L-P-H-A. Alpha is this, right? Beta is beta. Gamma, theta, delta. Delta is used a lot in physics. And also phi, which I missed here, which is written as this. We use in set theory also as a null set, phi. So these are common Greek symbols, which we always use in trigonometry. Mnemonic, to remember the primary trigonometric ratio is SOHCAHTOA, right? As I just summarized, the reciprocal relations are cosecant, which is 1 over sine, secant is 1 over cos theta, and cotangent is 1 over tan theta, correct? So from here, you can also notice that what is tan A? Tan A can be written as a ratio of sine A over cos A. Very interesting, right? Can you prove that tan A is ratio of sine A and cos A? Can you prove that? How will you prove?
So tan A is equivalent to sine A divided by cos A, sir?
Yes, yes. And how do we prove? Let me just show you. What is tan? In a right angle triangle, it is opposite side over adjacent side, correct? Correct?
Yes, sir.
You know that, correct? If I divide both with hypotenuse length, what do I get? The numerator opposite over hypotenuse is sine A, correct? You can see very clear.
Yeah.
And adjacent over hypotenuse is cosine A. So it's a ratio of sine over cosine. The hypotenuse cancel, and what you get is sine over cosine, and that is tangent of that particular angle, correct?
Yes, sir.
It's called an identity. So this is the first identity, we say trigonometric identity, since we have trigonometric ratios involved. This is always true. The only restriction is that the denominator cannot be 0. So in this ratio, we cannot have cos A equals to 0 because you cannot divide by 0, correct?
Yeah.
Right. So that is kind of important to understand. However, for all of the values, it is an identity. In its domain, it is valid for all the values. Is that clear to you?
Yes, sir.
Now let us see that if you are given a triangle, for example, here, we are given a triangle PQR. The sides of the triangle are PQ is 8 centimeters and QR is 6 centimeters. Can you see the triangle?
Yes, sir.
Can you tell me what is sine of P?
Sine of P, sir?
Yes.
It would be 6 by 10, which is equivalent to 3 over 5.
Very good. How did you calculate 10?
So basically, sir, the way I did it was like one way would be Pythagorean theorem, but
Yes.
the other way was by simply just dividing everything by 2, sir, because
Yes.
it's basically 3, 4, and 5 square.
3, 4, and
Triangle.
5. That is like my student. So that is a trigonometric triple, right? Pythagorean triple. So you remember the Pythagorean triples? Correct. So one of the Pythagorean triples is 3, 4, and 5. And as soon as you see 8 and 6, you know we're talking about twice those things. So the sides are in that ratio of 2 times. And so you knew that the hypotenuse has to be 10. So you don't have to really do 8 square plus 6 square root, which will give you square root of 100 and which will give you 10. Otherwise, normally, a student will do all these steps to derive at the result that the hypotenuse is 10, correct?
Yes, sir.
Very good job. So that is what I did, right? So for most students, they have to go in steps where you are a step ahead of them, right? Now tell me, what is secant P?
Secant P, sir, it would be 5 over 4 because secant P is like cosine's cofunction.
Excellent. Excellent. So you have already reduced the sides to 3, 4, and 5, and you're writing the answers in the simplest forms. Great job done. These are ratios. So you could always simplify the triangle sides into the lowest terms and then provide the answers one after the other, just as you're doing. Amazing. Can you tell me, in this triangle, what will be cos of r?
Cosine of r, so adjacent over hypotenuse.
Yes,
So 6/10. So 3/5, sir.
very good job. So you will notice that cos of r is equals to sine of p. Do you see that? Cos of r is basically equal to sine of p, 3/5. Why is it so?
Maybe because it's a Pythagorean triple, sir, or maybe because they both share the same
Co-function
hypotenuse.
identity.
Oh,
Co-function identity, right? You remember? Co-function identity. We are looking from the opposite side. Sine becomes cosine, cosine becomes sine, tangent becomes cotangent. Do you see that? So that's a review of our last class. I hope we have captured everything. And now let's move forward. Perfect. So equivalent trigonometric ratios now we'll talk about. So we have 6 of them now. We've got the 3 primary trigonometric ratios and 3 secondary. We already know some of the identities. One of the identities known to you is that reciprocal identity, right? Tan is cotangent, right? 1
yes,
over
sir.
1 over cot, correct? Or we could, this is the co-function identity. This is co-function identity, correct? So just now what we noticed is this, which is called co-function identity. So in a triangle, if you're looking from one angle and from the other angle, both the angles have a difference of theta, right?
Yes, sir.
If one angle is P, the other one is 90 minus P, right? So we have an identity that cos of R, which in this case is 90 minus P, is sine of P, correct? So remember that
Yes.
co-function identity. So we have come to the first, I should say the second identity. The first one is the reciprocal function itself, right? Cot is 1 over tan, secant is 1 over cos, and cosecant is 1 over sine, correct? So let me write this.
Yes.
Our identity, which is the reciprocal identity. Is it okay? You can also call this as reciprocal identity, correct? So that becomes our reciprocal identity. This is another identity. So we may call this as the first identity, since we just related sine A and cos A. This could be our second identity. And now we're talking about the co-function identity, which could be treated as the third identity, correct? So when you make your notes, put these things one after the other so that you can refer to them by name, and that will help you to remember them easily, correct? Now, let us explore the co-function identity. Perfect. Here is a question for you. The question is, in the triangle OPK, sine theta is cos K. Sine theta is cos K, right?
Yeah.
Explain if cos theta is sine K. Is the other thing also correct? Cos theta is sine K?
Yes, sir, because it seems to be like an equilateral triangle,
Not
meaning that
equal,
like all the sides would be the same.
not an equilateral triangle. It's a co-function identity, right?
Oh,
So you can see from either side. Is it okay? So this is also true because of co-function identity. Is it clear?
yes, sir.
Perfect. So yes, it is. Now let's move forward. In the coordinate plane, many times we have, those points, and those points can give us trigonometric ratios. For example, if I have a point P, which is 3, 4, as shown here, in that case, if I join the point P with the origin O, the concept here is, what angle will the radius OP make with the x-axis? Can you figure this out?
So basically, sir, point P is 3/4, right, sir?
Yeah.
3 x-axis, y 4-axis, and then we have to find out how much x is.
What is the theta angle? How will you find theta? From 3, 4. So we can do what is tan theta. So what is tan theta equals to?
Tan theta is opposite over adjacent, sir.
Which is 4 over 3.
4/3.
So we can actually calculate theta by taking inverse of this, right? So if I do inverse, it becomes tan inverse of theta, of 4 over 3. You get the idea?
Yes, sir.
Inverse reverses the whole operation. Now, for that, you need to use a calculator. So inverse function, you can apply with the shift key. So shift tan, that will give you the tan inverse. And then within brackets, write 4 over 3 and tell me, what angle do you get? Yes.
Oh, I got 53.13, sir.
Okay, so let me also check tan inverse of 4 divided by 3 gives us, oh, I have my calculator is in radian mode. Okay, let me just change it to degrees. So we have shift tan inverse of 4 divided by 3. 53.1, that is correct. Correct. So you can find the angle. So this is very important. Now, I can actually give you a very good application based on this, and that is to say, if I have line which is y equals 2, in this, if I go exactly with this question, the slope of the line is 4 over 3, right? Correct?
Yes, sir.
So if I have a line which is 4 over 3x, what angle will the line make with the x-axis? 53.1 degrees. You get the idea.
Yeah.
Even if I change the line, whether it's y-intercept as something else, let's say k, the angle will be same, right? So if I have a parallel line, the angle will be same. You get the concept. So theta, the angle which the line makes with the x-axis is tan inverse of y over x. You get the idea. For any coordinate
Yeah.
point. We could have known any coordinate point. For example, y over x, tan inverse will give us the angle which the line makes. So you see this value, which is the slope m in the equation y equals to mx plus b, right?
Yeah.
So therefore, tan theta is the slope of the line. Do you see that? So
Yes, sir.
you could correlate tan theta as m with the slope of the line. Very, very important conclusion from this particular example. And this is never told in the classroom, or it is not even mentioned in the books. You get the idea? But this
Yes,
is
sir.
a huge application which we will be doing. We can find angle between two lines using tan theta. For example, if I have another line which is kind of like this, we can find angle of intersection, so many other things we could do. And those are complicated questions which you will see in competitive exams. You get the idea?
Yes,
But
sir.
you are exposed to the idea, right? That's very important. Okay. So anyway, let's move on. I wanted to teach you only that part from that example. Now here, what are we given here? Can you please read example number 5?
Find other trigonometric ratios in sec A 13 by 12, secant
Secant
A
A,
13
13
by
over
12.
correct.
So given secant A equals 13 by 12, so secant A would be hypotenuse over adjacent.
Correct.
So sketch the triangle with given sides, then calculate the missing side using Pythagorean theorem,
Correct.
label for better communication.
Correct. So this is what I did. So we know that secant A, that means this particular angle, I'm just calling this angle as A, the vertex. And as you correctly said, secant A is hypotenuse over adjacent. It is reciprocal of cosine. And therefore, we get that triangle 13 and 12. The third side can be found using Pythagorean triple, which is, which you remember. If you don't, then you could do 13 square minus 12 square root. And what you get is 5, correct? So that is the third side, which is BC. Now, once you have the three sides, it is very easy to write down the values for the 6 trigonometric ratios. No big deal, correct?
Yes, sir.
That's good. Now, example number 6. Can you please read this example?
Explain why sine theta is never greater than 1 and secant theta is never less than 1. Secant theta equals the absolute value of secant theta.
Yeah, when I write with those bars, right? Secant theta, because it could be negative or positive. So that makes it always positive. Is it okay?
Okay, sir.
So this is called absolute value. What I'm trying to say is something like this. If I have minus 7 absolute value, it means 7.
Okay. Oh, so basically, like in the polynomials, right, sir?
Yes,
Like
yes, yes.
-7 square. Okay.
Yeah. So can you tell me why sine theta is never greater than 1? The maximum value could be 1.
It's because I'm not sure, but like I know for a fact that sine theta and cosine theta both share the absolute value of like one. They're never greater
Maximum.
than.
Yeah, why?
Yeah.
Think about their definition and then tell me. You are dividing by hypotenuse, correct? And
Yes,
the
sir.
side, which is the smaller side, it is never bigger than the hypotenuse, correct?
Yeah.
Hypotenuse is the longest side, and therefore the value can never be more than 1, correct?
Okay.
Yeah. If the angle is 90 degrees, then sine theta is equal to 1. And if the angle is 0, then cos theta is equal to 1. Is that clear to you?
Okay.
So remember one thing, that sine of 90 degrees will be 1 and cos of 0 degrees will be 1, right? Because when the cos theta is 0, then the hypotenuse is same as adjacent side, right? Height is 0.
Yeah.
Make sense? So
So
that is,
basically, they share a line, sir, right?
yes,
Because of last time, if it was 0, then sine would be 0 and cosine would be 90 degrees.
correct,
And if it was 90 degrees, then sine would be 1 and cosine would be 0.
correct, correct. Very good. So we have learned all this. Can you please read what this note is?
In right angle triangles, all trigonometric ratios are positive. When we extend angles greater than 90 degrees, in our coordinate plane, we will see that they do have negative values.
Correct.
Consider coordinate points in four quadratics, P bracket X by Y, and explore trigonometric ratios. Refer to student activity 2.
What I'm trying to say here is when we talk about a triangle, we are always saying that the sides are positive, correct? However, if I talk about a coordinate plane, right? So we have the XY coordinate plane, right? In that case, this is like minus values, right?
Yeah.
And the values here are negative y. And what we have just seen, that if I have a general point, let us say, let me just make a general point here, which is, let's say point is xy. Is it clear? Then, and this is r is the distance, where definitely r is equals to square root of x squared plus y squared. In that case, what is sine theta? Sine theta will be equal to what? It is the ratio of y over r, correct? The hypotenuse, correct? Now, if y is negative, if I have a point here, y is negative, right?
Yes, sir.
So sine theta will be negative. This is the idea. If
Yes,
y
sir,
is
because of Y point.
y is negative, if a point is here, let's say we have a point q in which is in quadrant 3, in that case y is negative. So in quadrant 3, sine theta is negative, right?
Yes, sir.
So you can see that the y value becomes positive and negative as we move from the quadrant. And therefore, what you notice is that the sine curve basically is kind of like this, right?
Yeah.
Sine wave. This is called the sine wave, and it changes from positive to negative to positive. It's a periodic sine wave. Think about something like a clock, right? Moving like this. Is it okay?
Yes, sir.
So it moves through positive, negative cycles as shown here, maximum being +1, minimum being -1, correct?
All right. So basically, sine theta in this graph example, right? It can go between a positive and negative, but never reaches over 1.
You are right.
But if we
And
look
now
at cosine theta, sir,
never will go below -1 also. So it is within
okay.
the absolute value of 1. Do you see that? So what
All
we
right.
say is that the sine theta is actually less than equal to absolute value of 1. Do you see that? So within plus and -1. So that is how we write it. Is that clear to you?
Yes, sir.
Now, question number 7. Application of complementary pairs, right? So we have been saying that if I look from this side and I'm saying sine of A, then from the other side the value will be cos of B, right?
Yeah.
Complementary, right? So basically, complementary angles are 90 minus theta. So they give us co-function identities. So this question here is that you will notice that writing decimal numbers in fractions help. In this particular example, we are given cos A is 0.75. You see, I've used decimal numbers now, correct?
Yeah.
And if I write 0.75 as 3 over 4, it is easy for us to make the triangle, correct?
Yes.
And easily we can say, well, this side is 3, the other side is 4, and that is how we could actually figure it out, correct? So 3 over 4 means we have 3 here and 4 in the hypotenuse. We can find the third side, and we can now write down all the trigonometric ratios, correct?
Yes, sir.
It is good practice to convert those decimal numbers into fractions and then work with trigonometry. Is that okay?
Yeah.
Correct. So this is what we're trying to say. And remember, cos A is 3 over 4. So we could write like this, which is the ratio of adjacent to hypotenuse. And once we know adjacent to hypotenuse, we can actually get the third side using Pythagorean theorem, as we just did. And once we get that, we can calculate all the trigonometric ratios, correct?
Yeah.
Right. That's what we're trying to say there. We did prove this was a student activity which we proved last time. You remember geometric mean?
Yeah.
Do it yourself once again. Write down. Make a triangle like this. Z is the altitude, right? So Z is altitude. Square of the altitude is equal to product of two sides, to product of the two uh, pieces of sides divided. Right? So this altitude divides that side into two sides. Do you see that?
Yes, sir.
So just product of those two sides is the same as the length of the altitude square. Is it okay?
Yeah. So it's basically z equals the square root of xy, right, sir?
Yes, z equals to square root of xy, which is geometric mean. Is it okay?
Yeah.
Perfect. So we have some examples now to go ahead. So this kind of an example. In questions 1 to 3, find exact value of primary trigonometric ratio, sine theta, cos theta. That's simple. You can do that, right?
Yeah.
No problems, right? You can do all this. So I'm just moving ahead. Now, many times we need to rationalize the denominator. What I'm trying to say here is, if I have a 45 degrees and if I get sine of 45 degrees, I will say it is equal to 1 over square root 2. Do you agree with me?
Yes, sir.
Correct. But writing square root 2 in the denominator is not a good way. We normally rationalize. Have you done rationalization?
I never done it, sir, but I think I know how to solve it.
Yeah. So you multiply and divide by the square root. When you
Square
do that, in that case, you get square root 2, and square root 2 times square root is 2. And therefore, many times we'll write this answer as square root 2 over 2. You get the idea.
Yes, sir.
So that is what is called rationalization. That you should do in addition to what we are working here. So mathematical skills should be known to you, right? Anyway, so based on this, we have some more examples given here. I'll just leave it as such, but later when you watch the video, you can actually stop and answer all these questions. Is that okay?
Okay, sir.
Yeah, well, I think you have understood all this. So, and basically, what am I doing? If I am given two sides, I'm trying to find the third side using Pythagorean theorem and then finding all the trigonometric ratios. Is that clear to you?
Yes,
Now,
sir.
that brings us to the first exercise of what we have done so far. The first question is, find exact value of primary trigonometric ratios for each of the given angle theta, right? This is your first exercise. But now, let me add this, that I will say find theta. So let us take this particular example, question 1C. Can you tell me what is theta equals to? And how will you calculate? Tell me.
So theta is, so first we have to find out the opposite side, sir.
Not need, not
So,
needed, not needed. You can use a
oh, not
trigonometric
needing
ratio.
this.
Which one can you use? You are given the two sides and an angle. So which ratio will you use? Tell me.
Maybe cosine, sir?
Cosine is correct because cos theta is adjacent over hypotenuse, which is 5
Hypotenuse.
over 10, which is equal to half. And so we know that theta is equals to cos inverse of half. Do you know from special triangles, which we did yesterday, what triangle does it work out? When is cos theta half?
In
Remember. Tell me.
is it the 30, 60, 90 triangle, sir?
Yes, yes. So cos theta is half for theta equals to 60 degrees. So you could use special triangles sometimes when you get these values as half or square root 3 over 2, right? And then get the answer without calculator. Perfect.
Yeah.
Right. So that is how you could do it. Now, here is a very interesting question right there. So question number 2 is, write the expression for three primary trigonometric ratios. Now, can you tell me, in this particular case, what is sine theta?
Sine theta,
You
it
have to use this
would be,
opposite side, right?
yeah.
Tell me what is sine theta.
So a square plus b square subtracted by a square minus b square of the
Whole
square root.
square, whole square. A square plus b square whole square minus a square minus b square whole square root will give you this particular side. Do you see that?
No, sir, I'm lost.
Homework. So let me just erase this part and give you a hint, right? Now let's work it out. It's a very interesting question. It's also a formula for Pythagorean triple in a way, correct? Okay, so you have to find a smaller side. Obviously, the smaller side is what? It is square root of longer side square, a square plus b square whole square minus a square minus b square whole square, correct? Have you done the factoring a square minus b square is what? A plus b times a minus b. Do you know that?
No, sir.
Okay, and do you know what is a plus b whole square equals to?
Wait,
A
a
plus
square
b
plus,
whole square.
I
What is
think so, sir.
a plus b whole square equals to? Tell me.
Would it be a square plus b square? I
Plus
mean, my bad. A square plus 2ab plus b square.
right. And if I have this as negative here, then this will be negative here. Do you see that? So basically, the two AB terms is positive or negative, correct?
Yeah.
So when I expand this, a square plus b square cancel, but I will have 4ab here, correct? Which is 2 square root ab. So this side is 2 square root ab. And now you can write down the trigonometric ratio.
Yeah, sure.
You get the idea. So you could have this kind of a question in your test. And there are many other questions here which you can see, right? So we'll just move on with this particular thing and fine. Now it says question number 4. Sketch a right triangle for the given trigonometric ratio. Tan of 31 is 0.6. How will you sketch this particular triangle?
Tan of 31 equals to 0.6.
How will you sketch this triangle?
So
You don't need protector.
okay.
Sketch. Okay. There are two things. When we say sketch, it is a rough sketch. When we say graph or something like that, then say you need more, accuracy. Is that clear to you? So we are saying tan of 31 is 0.6. What does it mean?
So basically it may be 0.6 for 10.
0.6, write it in fraction 6 over 10, which can be simplified to 3 over 5. So it is 3 over 5. Do you understand now?
Yes, sir. So that
That
would
is how
be
you
the
sketch.
adjacent and hypotenuse.
No, tan, a positive over adjacent. 10,
I
10.
mean, yeah.
You get the idea? So in this question, you have to convert the decimal into fraction and then you can make your triangle. Otherwise, well, you could have written zero point 0.6 and 1, correct? You could have written what? 0 0.6 and 1, correct? Ratio. You could write this over 1, correct? For example. But writing a whole number is a better thing and expected from you, correct?
Yes, sir.
Right. Now, we have this particular question which says secant theta is cosecant theta. When is it possible?
Oh, secant theta is greater than cosine theta?
No, secant theta is equal to cosecant theta when?
On a
So,
different point, sir.
which point?
So for an example, secant, wait, they have
Secant
to be on
theta
point A, right,
1
sir?
over cos theta is equal to 1 over sin theta. Is that clear to you?
Yes, sir.
Let's cross multiply. So we get what? We get sin theta over cos theta is equal to 1. What is sin theta over cos theta? Tangent of a theta. When is tan
Tangent.
theta equals to 1? 45 degrees. When we are talking about angles in a right angle triangle, right? So right angle triangle means that the angles are less than 90 degrees. So for 45 degrees, we know this will be true, right?
Yes, sir.
It is also a cofunction identity. If you see, this is a cofunction identity, correct? And if both are equal, right? 90 minus theta, but they are making the same angle, theta, theta. So the two angles have to be same, means it is an isosceles right triangle. Is that clear?
Okay.
So we say it's an isosceles right triangle. Is that clear? And that will
Yes.
also help you to write down the answer. Is that clear?
Yes, sir.
Now, question number 5a. When is sine A greater than cosine A? Tell me.
Where sine A greater than cosine A?
In a right
Yeah.
angle triangle. When measurement of angle A is greater than 45 degrees, correct? If that happens, at 45 degrees, both are same. Do you see that?
Yes, sir.
But as soon as the angle moves beyond 45 degrees, the height is more than the adjacent side.
Okay.
Bigger the angle, longer the side, correct? For same angles, both the sides are same length. So for sine A being greater than cos A, the angle A has to be greater than 45 degrees, correct? Only then it is possible.
Okay.
You get the idea? So these are
Yes,
very
sir.
interesting questions for you to attempt. Can you please make a note of question number 7? Can you read this question?
A kite is flying 40 kilometers above the ground with string length of 60 meters.
Mhm.
Calculate the 6 trigonometric ratios and their exact values.
Correct. How will you do it?
So 60 meters would have to be the hypotenuse. Then 40 meters would have to be opposite. And then we have to just find theta. So that would be,
That's
you
the
can
ground.
first do.
Correct. So this is your kite, correct? Correct? So that is
Yes.
how you're going to do it. Very good. So we know those angles and you can do all these questions. Do you see that tan theta solution here?
Yeah.
It should have been square root. It should have been square root, right? Oh, it was,
Oh, yeah.
yes, yeah, it is correct, 2ab, because it should have been 2a square b square. Yeah, when I multiply, I get a square b square.
Okay.
Because it was a square b square inside, right? So this is how you're going to do it, correct? So what you notice here is that these numbers, a plus b, a minus b. So we have a triangle here. Let me again make this particular triangle, very interesting triangle, correct? So we are saying that one side is 2ab, the opposite side is a square minus b square, and the hypotenuse is a square plus b square. Do you see that?
Yes, sir.
If you give different values to a and b, you get the whole numbers. Of course, you want to put A greater than B, correct?
Yes, sir.
So A greater than B means you could have A as 2 and B as 1, right?
Mhm.
So if you put 2 and 1, what do you get?
So we would get
So
4 square plus.
here it is 4, and 2 square is 4, 4 minus 1 is 3, and 2 square is 4 and 1, you get 3, 4, 5. Do you get
I,
Pythagorean triples?
yes, sir.
So that is a formula for getting Pythagorean triples. Make a note. So make a table with the sides as 2ab, a square minus b square, and a square plus b square. Substitute different values of a and b, where a is greater than b, you'll get all your Pythagorean triples.
Okay.
Starting with like 2, 1, 3, 2, 3, 1, but a should be greater, right? 5, 2, 5, 3, 5, 4. You get the idea?
Yes, sir.
4, 3, 4, 2, 4, 1. You get so many Pythagorean triples. So that is how you can get your Pythagorean triples. And this example is an excellent example from that respect. You get the idea?
Yes, sir.
Perfect. And as you can see here, tan of 31.6, we wrote 0.6 as 6 over 10, simplified to 3 over 5, which gave us this particular triangle, right angle triangle, from which we can find all the angles and the sides and the trigonometric ratios, correct? So
Yeah.
writing decimal numbers into fractions help. So many questions like this. Another set of questions, I said these are the solutions of the questions which we just read, right? So that brings us to the end of this exercise. So we have understood how to work with sine theta, cosine theta, correct? And what kind of questions we could expect in this. Get an idea?
Yes, sir.
So that's a lot of work which we have done today. But I'd like you to now at this stage watch some of my videos. And again, go through this. We quickly went through the questions and their solutions. The reason is very simple. I want you to solve all the questions in exercise 1 yourself. And then you may go through this video and see their solutions just to check your answers, correct?
Yes, sir.
Great. So we're going to end our class here today. Any difficulties? Tell me. Any concept
So
which is
far,
not clear?
no, sir, I have no difficulties.
Perfect. I like that part. So, okay. Can you please summarize today's lesson?
So basically, today we started to talk about the cofunctions, and then we also started looking at some equation with the algebra equations like a square plus b square, so on and so forward. And then also looking at how secant theta and cosecant theta both are found equivalent in isosceles triangles, and when sine A or sine or cosine A, which one are same and when are they same and when are they greater?
Great.
So these are some of the things along with the advanced parts of the cofunctions.
Very great job. So keep in touch, and whenever you have difficulties in this topic, just WhatsApp to me and I'll share the solution or the suggestion with you. Is that okay?
All right.
So have a great day. See you next week.
All right. Thank you, sir.
Thank you. Bye.